This is Prakalya, and here is a case study on data structures. The case study is how hashing is implemented on dictionaries. Hashing based dictionaries are one of the most fundamental data structures in computer science, in both theory and in practice. They have been intensively studied for decades, and numerous results have been obtained in many memory models. In this survey, we'll try to cover some basic approaches and techniques for designing hashing based dictionaries. In this case study, we'll be approaching or comparing the hashing techniques implementation for dictionary. A dictionary is a fundamental data structure. The basic object for dictionaries are keys and data items. A dictionary stores a finite set of keys where each key is associated with a data item. The operations of dictionary are to construct a dictionary, to insert the values into the dictionaries, delete the value from the dictionaries, and search for the value in the dictionary and destroy the dictionary. Many different implementations for dictionaries are known. Most of them are based on hashing or on search trees. In this study, we'll consider practical experiments with an implementation of dictionary based on dynamic perfect hashing. Applications of dictionaries are data type or dictionaries are useful in any type of application where further information is associated with the given key. The obvious examples are dictionaries of words, number pairs, calendar dates, even description pairs. Dictionaries are frequently in analysis for printed text. For example, a concordance examines each word in a text and constructs a list indicating on which line each word appears. Here are some types of hashing. First is linear probing with constant independence. The analysis of hashing with linear probing is usually considered as the birth analysis of algorithms, and it still is attracting a lot of attention nowadays. The first known result on hashing with linear probing was given by Smith, where that shows big O long n wise independence is sufficient to achieve essentially the same performance as truly random function does. The main reason for this is that in the theorem, big O long n wise independent event have probably bonds only different from the full independent case study on O 1 by n. However, big O long n wise hash function is still expensive and evaluated. Recently, a breakthrough result published by Paul showed that constant independence is sufficient to achieve a constant bond. More precisely, they have showed 5-wise independence is enough to ensure a constant expected cost per operation, while wise pair independence may lead to logarithmic cost per operation. And the next is perfect hashing. Chaining with universal hashing and linear probing with 5-wise independence have a solid theoretical basis. However, these bonds are still expected constant, and bad performance could very well occur. Perfect hashing is a technique that achieves worst case performance guarantee, and in this session we'll study about that. Cuckoo hashing. The dynamic perfect hashing table discussed in last session have been described performance guaranteed, but it is too complicated for implementing. Cuckoo hashing is a process that same theoretical properties are done, and it is much simpler. There are three types of cuckoo hashing. It is no cycle, one cycle, and two types of cycle. As according to the analysis, linear probing is a better type of hashing that can be used for implementation of hashing for dictionaries. The algorithm and implementation for linear probing hashing are as follows. The basic primary operations of hash table are to search, that is search an element in a dictionary, and to insert an element in the hash table, and delete is delete from the element in the hash table. First is data item. Define a data item, have some data and key based on which search is to be done. And here is the routine. First we'll create a structure and initialize the key and the data. And the next is followed by hash method. It is defining the code of the key of the data. First we'll be initializing and calling the hashing function, and we'll be returning the key size. The next is the insertion method. Whenever an element is to be inserted, compute the hash code of the key and past locate the index using the hash code as index in the array. Then use linear probing for empty location if an element is found, or computed hash code. First, the routine is we'll be creating a structure, and we'll say that the item tends to data will be data, and the item tends to key will be the key. We'll get the hash, we'll move in the array, and we'll be moving until it is called an empty, or it is the deleted cell, and we'll go to the cell wrap around the table, and we'll be implementing the item. The next is deletion. Whenever an element is to be deleted, compute the hash code of the key passed and locate the index using the hash code. Use linear probing to go to the element ahead if an element is not found, or computed hash code. When found, store a dummy item there to keep performance for hash table intact. And here is the routine for deletion. First, we'll be initializing it, and we'll say that int key will be the item next to key. We'll get the hash move in array until an empty, and we'll be giving an if loop, and we'll be initializing an item called temp, and we'll be assigning a dummy item and at deleted position. We'll be calling the next item, we'll be wrapping around the table, and we'll be returning to the null value. Next is to search the algorithm. Whenever an element is to be searched, we should compute the hash code of the key passed and locate the element using the hash code as index in the array. Use linear probing to the element ahead if element is not found at computed hash code. First, we'll get the hash, we'll be moving until the array is empty, and we'll be moving into the if loop, and we'll say that the a of hash index tends to key is equal to key, and we'll be returning the hash index. Then we'll call the next, and we'll wrap around the table, and we'll return null. So these are the implementations of dictionary in hashings, and the tools used for implementation are test driver. Our test driver compiles with the input file specifications described by mecgeo. The input files, the data is the ASCII value. The driver reads the input and converts the ASCII values as C data and calls the appropriate dictionary operations. However, the scanf command used to convert the data is a very expensive C operation. Most of the CPUs tend to be done by this. And thank you.